It's math time with Heinz. It's math time with Heinz. It's math time.
Hi everybody, welcome to lesson 10 where we're going to solve systems of equations. So let's get into it by looking at a graph here. So consider the equations x plus y equals negative 2. So I have x plus y equals negative 2 and y equals x squared minus 4. So notice that I have a linear function and over here I have a quadratic function because it's x squared. So graph both of these functions. Well, to graph a line, it's got to be in y equals negative x minus 2. So you could go to your calculator, or you can say I'm going to start at negative 2, and then I have a slope of negative 1 and go this way from there. Or you could have went to your calculator, but you are in 11th grade and should be able to graph a line. Gonna make that nice line there. And I'm going to label it because I'm graphing two different things. That's step one. I'm going to pause the video if you need to catch up, but that's graphing the linear equation there, y equals negative x minus 2. Now we got to graph the quadratic equation over here. The quadratic equation is y equals x squared minus 4. So you're going to go to y equals on your calculator and type that on in. I don't have my calculator up right now, so I'm just going to do it from the top of my head. I have a vertex at negative 4, and then these points are on the graph. And there's my parabola. That's a pretty good sign right there. Pretty good parabola for using the computer here. So y equals x squared minus 4. So again, pause the video. Make sure you can do that on your calculator. Go to y equals and go to the table to plot those points. So what do I care about? Where are the solution? The solution of the system are the 2 points where they intersect. So it's at the point, 1, negative 3, and negative 2, 0. Those are the solutions to the system of equations. There's 2 of them. This line and that parabola intersect twice. Algebraically, how do I solve this system? Well, algebraically, we use substitution. I get y by itself, like I did above, and I plug it in. So 2 equals negative 2, my fault. So we get y by itself, so y is the same as that. So over here for y, I'm going to replace it. That was supposed to be a pen. I'm going to replace it with negative x minus 2. Y is x squared minus 4. And when we solve quadratic equations, we set it equal to 0. So x squared plus x plus minus 2. I set it equal to 0 so I can factor it, and I'm going to ask myself, what multiplies to negative 2 that adds to positive 1? Well, x plus 2, x minus 1. So I get x equals negative 2 and x equals 1. And at this point, you think you're done. But you're not, because when we solve a system of equations, we need to take both of these values and plug them back in to get their y values. So I get negative x, so the opposite of x. So I'm just going to plug in a positive 2. Y equals the opposite of x minus 2, which is 0. So that's the point negative 2, 0. That's one of the points. Or y equals the opposite of x, negative 1 minus 2 is negative 3. 1, negative 3. And these points look identical to what we got graphically because we solved the same system. This time I was just doing it algebraically. So given a quadratic function, so a parabola and a line, what could happen? So there's 3 possibilities. If I have 3 parabolas here, here's what could happen. The line could cross through it twice. I could have 2 solutions to the system. I could have one solution if the line is tangent, is what we say. Notice how they intersect once, one solution. Or it could be a complete miss and we have no real solutions. And we know if we have no real solutions, that means the number I is going to be popping up if I solve a system of equations like that. But most of the times when we get that, we just say there's no real solutions and move on. We don't really deal with the I's when we deal with this system of equations. So you can cross twice, it can cross once, or it could not cross at all. So find the solutions to the system of equations. So y equals negative 2x plus 3. Wherever I see y, I'm now going to replace it with y equals x squared minus 6x plus 3. Add 2x over, minus 3, minus 3. Got it, equal to 0. X squared minus 4x, that also goes to 0. So this isn't the difference of squares, as tempting as it is to do x plus 2, x minus 2. This is really just a GCF. So I get x equals 0 or x equals 4. But again, we're not done. Once you get your x values, you've got to plug it in. Y equals negative 2x plus 3. Plug it into the linear one. You could use the quadratic one, but why are you doing more work? Plug it back into the linear equation. So we get 0, 3 is 1 point of intersection, and negative 2 times 4 plus 3 gives me negative 5. So 4, negative 5 is the other point of intersection. So again, when we see a system of equations, I've got to plug one of the equations into the other and solve. Once you're done solving, you feel like you're done, but you still have to go back and find the other variable. All right, this was on my Algebra 2 trig regions way back when I took this test. This was my 6-point question. Let's see how we do here. Solve the following system of equations algebraically. So I have some sentimental connection to this problem here. Well, let's start with this. 5 equals y minus x. Well, if I add x to both sides, that gives me x plus 5 equals y. So wherever I see a y, I can replace it with x plus 5. So wherever I see a y, I'm going to replace that y with x plus 5. And those parentheses are kind of useless there. I'm just going to combine like terms. So I made that substitution with y and x plus 5. Well, it's x squared, so I'm going to get it equal to 0 by moving those terms to the other side, because I'd rather factor a positive x squared. I'd rather deal with a positive x squared than a negative x squared. So you got two choices right now. You could factor it, or you could use the quadratic formula. I'm going to factor it just to practice factoring. So I'm going to ask myself, what multiplies to negative 36 that adds to 16? What multiplies to a times c that adds to the middleman? Well, hopefully you realize we're going to split that up as 18 minus 2. Hopefully you realized 18, positive 18, and negative 2 were the answers. So I'm going to take out a 2x when I group now. So I better get 2x plus 9 over here, negative 1. There we go. AC method is going to be popping up a whole lot, folks. So if you're struggling with factoring something like this, you've got to reach out. X equals negative 9, but I got to divide it by 2. Or x equals positive 1, but I've got to divide it by 2. I think decimals might make a little bit more sense here, negative 4.5 and 0.5. That's x, negative 4.5 and 0.5. I now need to find their y values. How do I do that? We plug it in. We take those values and go all the way back to the beginning. Y equals x plus 5. Y equals x plus 5. So that gives me 1/2 for that y value. Y equals x plus 5. So the other y value is 5.5. And those are the solutions to my system. You could have used the quadratic formula, but I chose to use the AC method because it was actually factorable. But when in doubt, use the quadratic formula. Got 2 more problems and we're done here. Well, really 1 more problem. Instead of just dealing with parabolas, we're also going to deal with circles. So if I have, let's see how I do here. If I have 3 circles, nope, didn't want to. If I had 3 circles, no, just going to pretend like these are coming out as circles. There we go. There we go. If I have 3 circles, what can happen if I draw a line? Well, it's the same as the parabola. It's the same as the parabola. They can intersect twice. 2 solutions. It could be tangent again, and I could have 1 solution that's repeated. Or it could be a swing and a miss, and we could have no real solutions. So again, when we solve a system of equations, we're looking for points of intersection between a circle or a parabola and a line. Let's do one algebraically here. Find all solutions to the system of equation below. So notice that this is a circle, and it's been a while, and you learned circles during COVID times. So it's something squared plus something else squared equals r squared. So the center of this circle, this is good SAT review here, it's opposite, opposite, 2, -3, with a radius of, well, that's the radius squared. So what's the square root of 4? The square root of 4 is 2. So that circle, hopefully you remember that. If not, that's okay, because we're going to be doing things algebraically mostly this year. The circle has a center at 2, -3, and a radius of 2. So I'm going to go 2 in each direction. And there's my circle that I'm going to attempt to draw. That was okay-ish. That was okay-ish. There we go. It's close enough for me. So there's my circle, centered at +2, -3 with a radius of 2. And now this line here, I've got to do some work. I've got to clean up this line. So let me get y by itself. Let me get y by itself. Y equals x minus 3. So I'm going to start my line at -3, and then I have a slope of +1. And there's my line right there. Come on, ruler. Uh-oh, I froze. I froze. Redo. There we go. I want my ruler. There it is. So my points of intersection are, here they are. The solution to this system is 0, -3, and 2, -1. Those should be my solutions. So let's solve it algebraically. Let's now solve, I believe that's what it says too, graphically and algebraically. So I got x minus 2 squared plus y plus 3 squared equals 4. So again, it's substitution. I already got y by itself. So again, when we do these algebraically, you're going to have to get y by itself. And now what I need to do is plug it in. Wherever I see a y, I know it's tempting to start making boxes right now, but don't start making boxes until you've made that substitution. Y gets replaced with x minus 3. So x minus 2 squared plus x minus 3 plus 3 squared equals 4. Because look what happens here. Those 3's cancel out or add to 0, and I'm left with this. So all I need to do right now is make a box for x minus 2 and x minus 2. So x squared minus 4. Sometimes you have to make 2 boxes, and that's okay. Sometimes you have to make 2 boxes, and that's okay. So I get x squared minus 4x plus 4 plus x squared equals 4. Combine like terms. Nope, doesn't equal 0 yet. I need it to equal 0. So 2x squared minus 4x equals 0, which means I've got a GCF. And we're left with x equals 0 or x equals 2. Again, those are my x values. Remember, there's that step that you still have to plug them back in. So if x is 0, 0 minus 3 is 0. So 0, negative 3. Or 2 minus 3 is negative 1, which is what we got up above. So when we work with circles, we can't panic because they look crazy. We can't panic because they look crazy. You're still going to do substitution, and then sometimes you have to make two different boxes, combine like terms, and then solve. We get to do a lot of good algebra with these systems of equations, and when we're in class together, we'll practice them.